So the idea of moles can be divided into three main categories. One such is, we've already covered it, when you're talking about moles and mass. Okay? The other is moles and gases, which is the math and the logic is completely different. And thirdly, when you're talking about it in terms of solutions or concentrations. So we kind of spent a lot so far talking about the mass bit. Now we talk about moles and gases. And honestly, I think this is the easiest. It's straightforward. There's nothing here. The only reason people get this wrong is they probably think it's harder than it is and get confused. So let's get started with that. So earlier, what we were talking about was 1 mole of any compound would have a mass of equivalent to its MR. That's practically why MR exists, because we can find out its weight and use its weight to find out its mole. Okay. But with gases, when you're measuring their volume, it's different. The rule is 1 mole of any gas. What gas? Any gas. Could it be that gas? Yes, it can. Any gas occupies 24,000 centimeter cube of volume, right? It could be, again, any gas. Do not get confused by the number of gases. Any gas, you don't even have to know what gas, right? If it's 1 mole, it's 24,000. And with that same logic, if it's 2 moles, it's going to be times 2 of this value, 48,000. If it's 3 moles, I don't know what 24 times 3 is. 72, I think. Whatever, right? Do the math. If it's half a mole, it's going to be 12,000. Okay. What is the volume of methane, of 1 mole of methane? Well, is it a gas? Yep. So it's going to be 24. 1 mole will always be 24,000. Okay? Ammonia, is it a gas? Is it 1 mole? Yep, 24,000. If it's 2 moles, well, that's just going to be times 2 of that. O2? Yeah. So if you remember the formula for volume and moles of a gas, it's going to be, it's a terrible N, it's going to be moles are equal to the volume of a gas over 24. You know how earlier we were using mass over MR? MR was the molecular mass of the compound. There's no such value here. 24 is a constant. The equation doesn't know what gas you're talking about because it applies to all gases. Whatever volume you put in, divide that by 24, you get the moles. Okay, here's a trick question. And be wary. It's a trick question. What is the volume occupied by 1 mole of steam? Well, steam is, H2O, which is a gas. Steam is a gas. Okay. All right, you gotta be very careful, not that they trick you too much, but it's easy to get confused. This applies, gases expand on heating. So 1 mole or 24 centimeter cube, I should have written this earlier, is true for room temperature and pressure, 25 degrees Celsius RTP, right? 1 atmospheres. Okay? It's true for that value. For any other value, and we don't really talk about moles in any other value. Okay? So you won't come across that question. But if you get something like that, because people just they see this, they see 1 mole, and they think it's talking about the volume for some reason. Maybe it could be talking about something else. And they try to, instead of figuring out the mass for it and then using that, they try to apply this concept here. And that's just not going to hold true. Because this steam is a gas at what temperature? Any value higher than 100 degrees Celsius. So it doesn't, that same rule doesn't apply to it. Sure. And at 25 degrees, steam will not be steam. It'll be water. It'll be a liquid. So that rule goes away. So be wary of that fact.